So we're just talking about waves and waves on the surface, and of course we need to mention this idea of wavelength. The traditional way to do it is to talk about the length between crest to crest, um, but you could also go from trough to trough. That those values are absolutely equal. Um, all right, so this is what's happening in the deep water. Now what happens when a wave approaches the shore? All right, so waves at the shoreline in shallow water, that when the water gets to be about when the depth gets to be about half a wavelength. That's a very important number, right? When that happens, what happens is the wave will begin to notice. Well, not it's not conscious or anything, but it'll feel the friction. The wave begins to feel the friction of the bottom of the of the bottom of where the water where the water touches the land, or underneath the wave. Okay, so when that happens, and so that's happening right here. So this is this would be the wavelength right here, and then all of a sudden because the wave is getting into shallower and shallower water. That wavelength, it's now in a depth of about half that wavelength. So once that happens, what happens is that the wave will compress. So the wavelength themselves will get shorter. They'll get closer together, and then the wave will also slow down. So it's not moving as fast as it was out there in the open ocean, and the water will build up higher and higher, and then eventually what happens, of course, is the water breaks. What we mean by that is the water will reach a height that it can't support itself anymore, and it will spill forward, in the direction that the wave is traveling, and that sudden splash of water, that is very, very, very turbulent, right? That's if you've ever been at the beach, and you stand right there at the shore, it can be very, very turbulent. There's sand floating about, and sometimes little rocks are moving along. And so that area right there where the water is splashing around is called the surf, for good reason, right? Right. In fact, that's where the surfers, when you talk about people wanting to surf and stuff like that, they want to ride the wave just as it starts to approach the shore. Okay, so when a wave approaches the shore, this is a question. Um, the depth of water decreases. This affects the wave by flattening its circular motion. So instead of being circular, by the way, it becomes more elliptical. All right, so let's see what happens. Um, we get a decrease in speed. That's true. An increase in the distance. No, that's not true, right? The distance decreases. An increase in speed. Um, okay, so that's not it. The decrease in speed and a decrease in distance between the waves, causing the wave height to increase. That sounds pretty good to me. Let's look at the last one. The increase in speed. So B and D are out right away because the wave speed doesn't increase; it decreases. All right. So decrease in speed, decrease in the wavelength, right? The distance between the waves, and certainly the height goes up. All right, as the wave enters shallow water, the forward direction will be able to change. Remember, waves are, so the example I always use is this, right? I mean, light is a wave. We know that. And when you take, for example, a pencil, I mean, you might have seen this at some point, middle school or elementary school. If you take a pencil and you put it in a glass of water, a clear glass of water, it looks as though the pencil is bent, but it's not bent at all. You can pull the pencil out and you can show that it's not bent. It appears bent because the waves of light change direction when it goes from air to water, and so that makes it appear as though it's bent. Now this that really happens with light, and this really happens with waves, with water waves, right? Water waves, as they approach the shore, they will change direction, and that's so another term for that is called refraction. So it refracts, and as the wave nears the shore, it slows and lags behind the incoming waves. The incoming waves also begin to slow and pivot, and basically what this is going to give us our here I'll show you. So this is what's called as these waves pivot. Once they get perpendicular to the shore, it's called a longshore current. All right, so the longshore current goes this way. By the way, remember you probably heard, if you ever spend any time at the beach, could be cautious when it comes to what are called rip currents. Rip currents go, excuse me, go perpendicular to longshore currents, so that they can take you out to sea, and that's why they're very, very concerning. All right, so anyhow, this is just what happens just due to refraction. So there's refraction, and once it gets to be parallel, it's called a longshore, or nearly parallel. It's called a longshore current. All right, so what happens along the shoreline? So the energy of the wave is as it's shown here, is unevenly distributed. So you get concentrations in these areas called the headlands, and these are areas of erosion, and then you'll get little coves and bays where you'll get deposition. You'll deposit some material in those areas. All right. So overall, this is what. So you just imagine that this is happening over the course of millions upon millions of years. And you have the wave is cutting in, these waves over time are cutting into the shoreline, and as rocks fall down, so as you get these cliffs. The rocks on top will fall down and drop into the sea, and it'll cause you to have these nice straight cliffs. So this has been happening for a long time, and as the waves pound over and over, they'll cause all sorts of things. Okay, so let's take a look at some of these things. So one is sometimes the waves will carve out some of the land and make a cave right next to the shore. They'll also carve out part of the land, and that's called a sea arch. And then suppose the sea arch gets broken, and just part of it remains out there in the ocean, and that's called a sea stack, right? If you go out and you see this area where it's kind of skinny right near the water, then kind of goes out a little, extends out a little bit. That's a sea stack, because what's happening, of course, is these waves pounding over time, over millions and millions of years. It basically have eroded this material, and caused this cave to happen, and even this curve, and the different sea cliffs as well. All right, so All right. Yeah. So the sea stacks are, just kind of the remains of these things way out there in the ocean. All right. Then characteristics of coastal depositional landforms. All right. So this is, when the water comes in, you'll start to develop a beach. So this is just basically sand being deposited. So this is usually just silica, right? Silica material. Silicon and oxygen bound together. Not organic. There are some places that have beaches that are more organic in composition. You see that a lot on the west coast of the United States. In fact, doesn't have as much of sandy beaches. They're dark because a lot of the material that's coming up right there, or that gets deposited, is actually organic material, and so it tends to be brownish, very, very dark, as opposed to like the sand. The sand is just little tiny pieces of rock, right? All right, and then what you do is you have these things called spits, and so the spits form first underneath the water, and then as time goes on, the sand builds up higher and higher and higher, and the spit will appear, you know, over the water, right? So you'll actually be able to see this sand. And then over time, these spits can develop into what are called barrier islands, right? I mean, if South Carolina and North Carolina have so does Georgia, has a whole bunch of barrier islands. Actually, you go up and down the coast, the east coast of the United States. There's a bunch of barrier islands. Some places have more than others, and anyhow, the barrier islands. Basically, this is deposited material, mostly sand in the case of the eastern United States, that it will eventually build up, and when it becomes an island, enough organic material is on this thing, on this, what was originally the spit, but you get enough organic stuff on there, and plant life will start to grow, and you'll actually have this full-fledged barrier island. All right, so and then of course, what else? This is also, this part right here is a tidal inlet. Sometimes these can really, it depends on what the latitude is. Like really far northern latitudes have these tidal inlets that were because of the tides, varies greatly, and it depends on the shape of the bottom of the water. The shape along the bottom of where the inlet is. These things can vary greatly, even more than like just the regular tides. All right, so let's see. So the ocean waves and tides and shores. Okay, so one of the things that we notice is right off the coasts of the land, around the world, you'll often have these coastal reefs that are there's living organisms that are actually inside of the coastal reef. That's not actually what you normally see when you think of a coastal reef. The thing that you're seeing is this calcium carbonate that has been secreted by these organisms. So it grows over time, and the actual organisms they're usually tiny little things. Some of them are bigger than others, and there's all sorts of creatures that get